Welcome back to Remarkable. In today's video, we're going to work through past paper questions from the non-calculator paper, which is P1 for O-level students and P2 for IGCSE. But before we jump into the questions, there's something really important I want to highlight. The syllabus now explicitly states this, that candidates are expected to use the geometrical properties listed in the syllabus when giving reasons for answers. Alright, so those reasons must match the ones listed in the official syllabus. I've put a screenshot of all the acceptable reasons up on the screen, so make sure you take a moment to note these down in your notebooks and ideally memorize them. They're really going to help you. So if any of the theorems shown here look unfamiliar or confusing, please go back and revise them. I've covered every single circle theorem in detail in the video shown in the thumbnail, so make sure you're completely confident with those before moving on. Alright, now that we're clear on that, let's dive into the questions. As always, I recommend that you pause the video and try each question yourself first. Once you're done, you can compare your solution with mine. Alright, so let's get started. Okay, so in the diagram, the points A, B, C, D, and E lie on the circle with center O. So the center is marked clearly. EC is the diameter. So if EC is the diameter, angle made in the semicircle or on the circumference by the diameter will be 90 degrees, right? So let's mark all the angles, 90-degree angles, and whatever we can find. Okay, so now they're saying OBA is 80 degrees. DEC is 59. So DEC is 59. BCE is 62. Find X. Okay, before that, as I always suggest and urge you to do, is mark the radii of the circle. So all lines originating from the center of the circle to the circumference. So the first line from the center to the circumference, second and third. So these are the radii of the circle. So let's mark them. Marking radius helps because you're able to identify isosceles triangle. So as you can see, hopefully, that triangle OBC is an isosceles triangle. So if this is 62, since this line and this line, they're equal, they're basically the radius. So this is also going to be 62, right? And if two angles, we know two angles are known of a triangle, we can find the third angle of the triangle. How is that? So sum of angles in a triangle is basically 180. So 62 plus 62 plus, let's call this theta, plus theta should be equal to 180, right? So theta is going to be 180 degrees minus, this is for 124. Okay, so theta is going to be 656 degrees. Okay, so let's mark this on the diagram. 56. Now, as you can see, 56 plus x, they lie on a straight line. So the sum of x and 56 should be 180 degrees, right? So let's use a different color. So x plus 56 is equals to 180 degrees, right? So x is equals to 180 minus 56, which gives x as 124 degrees. So x is 124 degrees. All right. Now we need to find y. Okay. Please notice that A, B, C, and E it qualifies as a cyclic quadrilateral. Why? Because all 4 points of the quadrilateral A, B, C, E lie on the circumference of the circle. So all points are on the circumference, so this qualifies as a cyclic quadrilateral. All right. And what is the property of cyclic quadrilateral? That the opposite interior angles of a cyclic quadrilateral are supplementary. They add up to 180, which means angle B plus angle E, this T, basically angle T, should be 180, and angle Y plus angle 62, A and C, should basically also add up to 180. So let's do that. So y plus 62 degrees should be equal to 180 degrees. So y is equals to 180 minus 62 degrees. Y is equals to 8 on 118. Okay, so I'm also trying not to use a calculator. I'm doing everything mentally. So check all my workings as well. All right. Okay, now let's have a look at angle Z. Okay, so for this part, let's focus on triangle DCE. So we know that angle D is 90 and this is 59. So angle Z would be, okay, so 59 plus Z plus 90 is equals to 180, right? So Z is equals to 180 minus 90 minus 59, which will give you 90 minus 59 is, so angle Z is 31 degrees. Okay, now we're left with angle T. Okay, again, we can use the cyclic quadrilateral property here. So this is 80 plus 62. So 80 plus 62 plus T should be equal to 180, right? So 80 plus 62, this is angle B, plus T should be equal to 180. So T is 180 minus 80 minus 62. So T is going to be 100 minus 62 degrees. So 38. T is 38 degrees. Also, there are more than one ways to find angles. As long as you're following logic and you get to the correct answer, but you're using a different method, a method which is different from mine, it is perfectly all right. Okay. Okay. So PQ is a chord of the circle with center O. So PQ is a chord. This is the center. X is the midpoint of PQ. If this is the midpoint of X is the midpoint of PQ, we can safely assume that OX is a perpendicular bisector of PQ. Okay, so this is a 90-degree angle. OXQ is 90 degrees. So OX is 6 and the radius of the circle is 10. Okay, so if the radius of the circle is 10, it means, okay, so it means this is 6 and, sorry, this is 10 and this is 10. Calculate PQ. Okay, so since we have a right angle triangle here and we know that OX is 6 and OQ is 10, let's first label the sides of the right angle triangle. So the length which is opposite to the right angle is the hypotenuse. Okay, and using Pythagoras theorem, we know that h square is equals to a square plus b square, right? So this is a and b, the legs of the right angle triangle. Okay, so if h is 10, 10 square is equals to 6 square plus b square. B square is basically 10 square minus 6 square, which is 100 minus 36, which gives you 64. Now to get rid of the square, we're going to take square root on both sides. This gets cancelled out, and we can write that b is equals to plus minus 8, but because b is the length, we are going to discard the negative value because length cannot be negative. Okay, so b, which is basically xq, is equals to 8, and we need to find pq, right? And we know that since x is the midpoint of the line pq, so, and we know what xq is, we're just going to double it. So pq is 2 times xq, so 2 into 8, which gives 16 as the answer. Okay, so pq is equals to 16. Okay, so A, B, and T are points on a circle with center O. AOD is a straight line. AOD is a straight line, and DT is tangent to the circle at T. So DT is tangent to the circle at T. TAO is 32 degrees. Find ATO. So which angle they're asking us to find? Angle ATO. Okay, but before that, let's mark all the radii. So all lines originating from the center to the circumference. So this, and this. Okay. This is equal to this is equals to this one. Okay. So since this is an isosceles triangle, right? If this is 32, ATO is also going to be 32 degrees. So this is 32. Okay, now they want us to find TDO. TDO. So this angle. This angle. Okay. I hope all of us remember the tangent property where the angle made between the radius and the tangent is 90 degree, right? So radius, tangent, 90 degrees. So this is 90. I would want you to focus on triangle OTD. Okay, this is 90. We need to find this angle. Is there any way we can find this angle? Yes, we can find it very easily. We know if we look at triangle AOT, we know this is 32 with this is 32. So we need to find the value of this angle. So this is going to be 180 minus 32 minus 32, which is 180 minus 64, which gives you 116. Okay, so if this is 116, angles on a straight line add up to 180, right? So this angle is going to be 180 minus 116, which is 64. So this is 64. Okay, so triangle ODT, if this is 90, this is 64, we can very easily calculate the third angle. So it's going to be, let's call this angle theta. 90 plus 64 plus theta should be 180 degrees. Theta is going to be 180 minus 90 minus 64. So theta is going to be 26 degrees. Okay, so let's mark it here. Angle TDO is 26 degrees. Okay, last they want us to find angle ABT. ABT. Okay, so let's mark it with red. Okay, now let's see. How can we find angle ABT? Okay, so see, here the property is not very visibly applicable, but that is something that I hope most of you were able to figure out while solving this question. So see, look at chord 80. Okay, so chord 80 is making an angle of 116 at the center, with the center of the circle, right? And then please notice that 80 is also making an angle at the circumference of the circle, right? So what is the property? Angle made at the center is twice the angle made at the circumference. So basically, you have to divide 116 by 2 and you will get 58. Okay? Why? Because we're applying the property that angle, wait. So focus on the chord 80. Angles made from the ends of the chord at the center, which is 116. So the angle made at the center is twice the angle made on the circumference. Please notice that angle ABT is being made from the ends of the same chord 80. These are the ends. And therefore, the angle made at the center, since it is twice the angle at the circumference, we're going to divide it by 2 to find the answer for the part C, for the last part. Okay? Okay, so in the diagram, circle the circle centers P and Q intersected B and E. Okay, so centers, this is the center, this is the center, and the circles, both the circles intersect at B and E. Okay, ABC and APE. ABC, this is a straight line, and APE, this is a straight line. BD is parallel to AE. Okay, whenever they tell you lines are parallel, please be ready to use some of the properties of parallel lines. So corresponding angles, alternate angles, sum of co-interior angles, something would be applicable. Okay, BEA, BEA is 36, BQC is 122, find BAE. Okay, before diving right into the question, let's see what angles can we mark. All right, so since APE is a straight line and it is passing through the center of the circle, we know that the angle made in the semicircle is going to be 90 degrees. So we will mark this as 90. Okay. Similarly, look at chord BC. Angle made at the center is 120. So angle made at the circumference would be half of what is it is at the center. So 122 divided by 2 would give you 61 degrees here. Okay, also since Q is the center, this is going to be, let's mark the radius. QC is the radius, QB is the radius, which means it is an isosceles triangle. All right, so this and this angle would be equal as well. All right, so the angles are going to be 180 minus 122, 58 divided by 2 would give you 29 and 29. Okay. Okay, now let's read the question. Let's see what they want us to find. So find angle BAE. BAE. So they want us to find this angle. I think this is very easy. Please focus on triangle BAE. This is 90, this is 36. So we can very easily find this angle. So let's call this theta for the time being. So 90 plus 36 plus theta should be equal to 180 degrees. Theta is going to be 180 minus 90 minus 36. So theta is going to be 54 degrees. So let's mark this as 54. Okay, find EBD. E B O is D. Okay, so EBD. This is what they want us to find. Let's use a different color to mark the angle. So they want us to find EBD. Okay, so how can we find that? Please notice that since AE is parallel to BD, these are parallel lines. Can you see what angle is being made here? So these are Z angles or alternate angles, right? So this angle is going to be equal to this angle because AE is parallel to BD. Okay, so this is going to be 36 degrees as well because there are alternate angles. So these are alternate angles. Okay, find BDC. BDC, great, we've already found that. BDC is 61 because angle made at the center is twice the angle made at the circumference. So this is 122, half of 122 is 61. Okay, find DBQ. DBQ. So this angle, let's mark it with another different color. This is DBQ. Okay, again, this is very simple. Why? Because ABC is a straight line. We know this is 90, this is 36, and this is 29. The sum of all these angles should be 180, right? Because they're angles on a straight line. So this is the only missing piece. So let's call this theta for now. So 90 plus 36 plus theta plus 29 should be equal to 180 degrees. So this is going to be theta is equals to 180 minus 90 minus 36 minus 29. Theta is 90 minus 65 degrees. So the angle is going to be 25 degrees. Okay. So I hope you're not struggling to solve these questions. Once you practice enough, you'd be able to apply all the properties very quickly and easily. Okay, so in the diagram, points A, B, C, and D lie on the circle. A, B, C, A, B, C, and D. They lie on the circle with center O, tangent TA and TB are tangents. So basically a tangent kite is being made. I hope you were able to figure that out as soon as you saw the two tangents in the question originating from one external point. AOB is 132, AOB is 132, ACD is 59, AOC is a straight line. So this is a straight line, and since the center lies on the straight line, this angle would be 90 degrees. So let's mark this as 90. Okay, we also know that because this is a tangent, let's mark the radii first. So all the lines originating from the center, so this is radius, this is the radius, and this is radius. So let's mark these. And we also know because this is a tangent kite, these two lines will also be equal. What is another property of tangent kite that can be employed here? That these angles add up to 180. These are supplementary angles, right? So the opposite interior angles of a kite are supplementary. So this would be 180 minus 132, which is 848. Okay, so this is 48. Okay, so they want us to find, what is part A? Find ATB. ATB, we've already done that. So it is 48 because the opposite interior angles of a tangent kite are supplementary. They add up to 180. Okay, next you need to find angle BDA. BDA. So this angle. Okay, now see. Please focus on the arc AB. The angle subtended by the arc at the center is 132, and the angle subtended by the arc at the circumference or on the circumference is going to be half of what is at the center. So basically this angle is going to be 132 divided by 2, which is 66 degrees. Okay, so this is going to be 66 degrees. Find angle BDC. BDC. Okay, so we know that this angle is 90 degrees and we know this is 66, so this angle would be 90 minus 66. 90 minus 66, which gives 424 degrees. Okay, find angle OBD. OBD. So this angle. How are you going to find angle OBD? OBD. Let's see which properties can be applied here. Okay, see. So if you, let's zoom this in. Okay. So let's look at the arc BC. Let's look at arc BC. So angle subtended by the arc at the center. So this angle is twice the angle subtended by the arc BC arc. This is the arc at the circumference, right? Okay, so we know that this angle, let's use a different, this angle is what? It was 24. Okay, so this angle is 24. So the angle at the center would be double of this angle, right? So angle, so this is going to be 48. All right. And we know that, let's zoom this in. Okay, so let's look at triangle, this triangle. Okay, so we know this is 24, this is 59. Can we find this angle? We can find this angle. So 180, 59 plus 24, let's call this angle theta. Okay, plus theta is equals to 180. So theta is going to be 180 minus 383 degrees. Theta is 797 degrees. Okay, so now since if this is 97, this angle is vertically opposite and this is also going to be 97. Okay, so now can we find OBD? So look at triangle OB and this triangle. All right, so this is 48, this is 97. We can find out this angle, right? So it is going to be angle OBD plus 48 plus 97 should be equal to 180 degrees. So angle OBD is going to be 180 minus So 35 degrees. Okay, so angle OBD is 35 degrees. I'm sure there must be another way to solve this question. So you can follow any method as long as it is logical and you get to the correct answer. Okay? Okay, question number 6. A and B are points on the circle with center O. Okay, so this is the center, this is radius, this is radius. Let's mark it right now. Okay. And TA and TB are tangents. So this is a tangent chi. This would be equal to this. And the radius and tangent make a 90-degree angle. Right? So these are all the circle theorems that I hope all of us are aware of. Okay. So what special type of triangle is ABT? I hope all of us know that ABT is an isosceles triangle, right? Because AT and BT are equal. So it is an isosceles triangle. Work out AOB. AOB. So this angle. Okay. Now because ABT is an isosceles triangle, this is going to be 64 as well. And if we know two angles of a triangle, we can find out the third one. So this angle is going to be 180 minus 64 minus 64 minus 8, 128 basically, which is 252. So this is going to be 52. And we know that the opposite interior angles of a tangent guide are supplementary. So 52 plus this angle should be 180. Let's call this theta for now. So theta plus 52 is equals to 180 degrees. So theta, which is basically AOB, is 180 minus 52 degrees, which gives AOB as 128 degrees. Okay, so angle AOB is 128 degrees. Okay, so there is a slight problem with the scanning, but these are straight lines, all right. Okay, so the diagram shows a circle with center O and radius 6 centimeter. So center O this would be 6. Tangents are drawn from T, so this is point T to touch the circle at point A and point B. OXT is a straight line intersecting the circle at X, and XT is 4 centimeters. All right. Calculate AT. So they want us to find AT. Okay, let's draw a straight line. Okay, this is AT. Okay, we know that the center and any line originating from the center to the circumference is the radius. The radius of the circle is 6 centimeters, so this is also going to be 6, right? Okay, so this is 10, 6 plus 4, this is 6, and this is a 90-degree angle. Why? Because the radius and tangent intersect at 90 degrees. So this is 90 degrees. So now what do we have? We have a right angle triangle. We know two of the sides. So this is 4, this is 10, and we need to find the third side of a right angle triangle. So what are we going to do? We are going to apply Pythagoras theorem here. We need to figure out which is the hypotenuse. So the length opposite the right angle is the hypotenuse. So 10 square, so what is Pythagoras? 8 square is equals to a square plus b square. hypotenuse is 10, so 10 square is equals to 6 square plus 80 square. So b is basically 80 square. 80 square is 10 square minus 6 square, so 80 square is 100 minus 36, which is 64. So 80 is going to be 8 centimeters, right? Even though the square root of 64 is plus minus 8, but because this is the length and length cannot be negative, we are going to ignore the negative value. 80 is going to be 8 centimeters. Okay, so in the diagram, A, B, C, D lie on a circle. Again, please understand that this is a straight line. There is a problem with the scanning here. Okay, so this is a straight line. Okay, so in the diagram, A, B, C, D lie on the circle. A, B, C, D lie on the circle. So A, B, C, D qualifies as a cyclic quadrilateral. Okay, CO is parallel to AD, DA. Again, please, since they're mentioning that lines are parallel, we might be able to employ some of the properties corresponding to parallel lines. Okay, the tangents to the circle at A and C meet at T. So these are tangents. Okay, let's mark the radius. So all lines originating from the center. So OA is the radius, AC is the radius. Angle made between the radius and a tangent is 90 degrees. So let's mark these as 90 first. Okay. Find X. So this is X. Okay. Let's look at the arc AC angle subtended by the arc at the center, which is 136, is twice the angle subtended by the arc at the circumference, which is X. So how can we find X? All we have to do is divide 136 by 2 in order to find angle X, which gives us 68 degrees. Okay, so angle X is 68 degrees. Let's write that down, 68. Okay, find angle Y. Let's see. So let's just make this diagram a little neat. So this is 90, this is 90, and this is 68. Okay. Okay, another thing that we can very quickly figure out is that since ABCD is a cyclic quadrilateral, if this is 68, angle Z would be, since angle Z and angle X, they're supplementary angles, right? So let's just figure out Z first. So 180, no, so 68 plus angle Z should be equal to 180 degrees. So Z is going to be 180 minus 68 to 112. So this is going to be 112. Okay. They also want. Okay, and we can also figure out angle T because this is a tangent kite and we know that the opposite interior angles of a tangent kite are supplementary. So basically 136 plus T should also be equal to 180. So T is going to be 180 minus 136. So T is 44 degrees. Okay, so angle T is 44 degrees. Okay, now we need to figure out angle Y. Okay, let's see. Okay, yes, see. Parallel lines, right? We have a transversal line. So sum of angles co-interior angles is 180. So basically for those who consider them as C angles, so this is a C angle. So 136 plus y should also add up to 180. Okay, so 136 plus y is equals to 180 degrees. So y is 180 minus 136, which gives y as 44 degrees. Okay, so whenever they tell you that two lines are parallel in one way or another, we can use the properties. So there are only three properties: alternate, corresponding, and co-interior angles. So see, this is a C angle or co-interior angles. They add up to 180. Okay, so in the diagram, A, B, C, D lie on the circle with center O. So A, B, C, D lie on the circle. AD is the diameter because it is passing through the center, which means that this angle would be 90 degrees. So let's mark it out right now. Okay. The tangent to the circle at B meets the line DA produced at D. Okay, so this is a tangent. Let's first mark the radius, all lines originating from the center. So this is the radius, radius, radius. Now radius and tangent make a 90-degree angle. So this is 90. Let's mark this as well. AOB is 68. AOB is 68. CAO is 43. Find X. Okay, so let's focus on triangle ADC. Okay, this is 90, this is 43. We can figure out what X is very easily. So 43 plus 90 plus X should be 180 because sum of angles in a triangle is 180. So X is equals to 180 minus 90 minus 43. X is going to be 47 degrees. Okay, so angle X is 47 degrees. Find angle Y. Okay, for that we need to focus on the arc AB. So for all those students who say that we are unable to figure out how the arcs are making angles at the center and the circumference, you just need to practice. Once you practice questions, you will be able to see them. Even before the examiner asks you, you will be able to figure out that the arc is making an angle at the center and then also at the circumference. So arc AB is making an angle, is subtending an angle of 68 degrees at the center, and the same arc AB, these are the ends, subtending an angle of y degrees at the circumference. Okay, so angle at the center is twice the angle at the circumference. So y is going to be half of 68. So 68 divided by 2 gives you 34 degrees. So y is 34 degrees. Okay, next you need to find angle C, which is this angle. Okay, again, so please focus on triangle BTO. This is 90, this is 68. We can figure out Z very easily. So 90 plus 68 plus angle Z should be 180. Why? Because we are looking at triangle BTO, this triangle. So this is 90, this is 68. Sum of angles in a triangle is 180. So Z is going to be 180 minus 90 minus 68, which gives Z as not 12, 22 degrees. Okay. Find T. Okay, so now we need to find angle T. Okay, see if we can figure out this angle, which we can, because this is a triangle, this is 43, this is 68. We can find this angle. This is vertically opposite to this angle, and we also know what y is. And then we can use this triangle to figure out angle T. Okay. Okay, so let's figure out this angle first. This angle. Okay, so this is going to be 180 minus 68 minus 43, which is 180 minus 1. So this is going to be 69 degrees. Okay, so this is 69. If this is 69, this is also going to be 69 because they're vertically opposite angles. And we know that y is 34. So this is 34. Okay, so if we focus on this triangle, this is 34, this is 69, we can figure out t. So t is going to be t plus 69 plus 34 should be equal to 180, right? So t is going to be 180 minus 103. So t is 77 degrees. Okay. So all of this working should have been here. Okay, so let's bring it down here. Okay, so here. Okay, so this is 77 degrees. Okay, question number 10. P, Q, R, S, and T are points on the circumference. PQ is equals to QR, PQ is equals to QR, which means this is, this is an isosceles triangle, so this and this angle would be equal. Okay, so PQR is 118, QRS is 99, find PTS and show your working. So you need to figure out what PTS is. Okay, so uh, if you look carefully, you can figure out that PRST is a cyclic quadrilateral. So all 4 points are on the circumference of the circle. So if we can figure this angle out, we know that this angle and this angle should sum up to 180, right? Because opposite interior angles of a cyclic quadrilateral are supplementary. Okay, so our aim should be to find or figure out this angle. Okay, we know that this is 99. Is there any way we can figure out what this angle is? Yes, we can. Because PQR is an isosceles triangle, these two angles will be equal. So let's figure out what this angle is. So it's going to be 180 minus 118, which gives us 62 degrees. And you need to divide 62 by 2, so you get 31. So this is 31 degrees and this is 31. Now, if this is 31, what is this angle going to be? It's going to be 99 minus 31. So this is 68. And as already stated, PRST is cyclic quadrilateral, so 68 plus this angle should be 180. So PTS plus 68 should be 180. So PTS is going to be 180 minus 68, which gives you 112 degrees. Okay, in the diagram, A, B, C, D, and E, A, B, C, D, and E lie on the circle with center O. AC is the diameter, which means this would be 90 degrees. So let's mark it right now. So this is 90. The tangent to the circle at C meets the line AB produced. So the tangent to the circle at C, so this is the tangent, meets the line AB produced at D. ACB, ACB is 62. ACD is 70. Find X. Okay, first let's mark the radius. So all lines originating from the centers of this and this will be equal. Radius and tangent make a 90-degree angle, right? So this is going to be 90. So then we can find X very easily because 62 plus X should equal 90 degrees because the radius and tangent intersect or meet at 90 degrees. So X is going to be 90 minus 62. So X is going to be 28 degrees. Okay, so X is 28 degrees. Now they're asking us to find B. Okay, so let's see. Okay, A, C, D, E, cyclic quadrilateral. Okay, all 4 points are on the circumference. And they want us to find angle Y. Alright. So if this is 70, Y plus Z should also, Y plus Z plus 70 should be 180. So this angle and this angle, they must add up to 180. Okay, so let's see. Y plus Z plus 70 is 180 degrees. Alright, so Y plus Z is going to be 110 degrees. So this entire angle is 110 degrees. Okay, what else do we have? Okay, we have another cyclic quadrilateral here. So look at the quadrilateral BEDC. Okay, so all 4 points are on the circumference. This and Z should add up to 180, right? So let's figure out what angle Z is. So Z plus 62 plus 70 should be equal to 180 because the opposite interior angles of a cyclic quadrilateral are supplementary. We are looking at the quadrilateral BCDE. Okay, so Z is going to be 180 minus 132. Angle Z is going to be 48 degrees. Okay, so angle Z is 48. If this is 48, all we have to do is subtract 48 from 110 to find angle Y, which is going to be 62 degrees. All right, so angle Y is going to be 62. Angle Z is going to be 48. There's also actually a very easy way to figure out angle Y, I just noticed. So see, if we look at chord AB, So angles made in the same segment. So this is angle 62. Another angle made by the chord AB is angle Y. Okay, so angles in the same chord are same segment are equal. So this and this must be equal. Okay, so it was very easy to figure out that angle Y is equal to 62 if we use the property that angles in the same segment are equal. Okay, again I have already stressed that there are more than one ways to solve an angle question. As long as you're using logic and you're getting to the correct answer, it's all right. Okay, so in the diagram, the two circles intersect at P and Q. So these are the two circles, right? And they intersect at P and Q. The line AB is tangent to the circle at A and B. So this is tangent. AD and BC. AD and BC are the diameters. Is BC making? No, they're not making any angles as of now. Okay. BD intersects the larger circle at R. BD, this is the line BD, intersects the larger circle at R. DBC is 40. Find CPR. Okay, so CPR, this angle. Oops, wait. Okay, so angle CPR is this angle. Okay, but first let's see what pieces of information do we have in order to figure out. Okay, since this is the center, this is the radius, this is the radius and tangent intersect at 90 degrees. So this is going to be a 90-degree angle. Okay, similarly, this is the radius, tangent, so this is also going to be 90 degrees. So let's mark this as 90 as well. Okay, what else do we have? Okay, so we know that okay, great. So the property that we just applied, if we focus on RC, the line which is not, basically it is an invisible chord. So let's draw it for our convenience. Okay, so now see, RC chord is making an angle of 40 at the circumference, and it is also making an angle RPC, right? So angles in the same segment are equal. So see, if this is, oops, so if this is 40, this is also going to be 40. Okay, so angles in the same segment are equal. So CPR is going to be 40. Let's write this down here. So this is 40. Okay, next they want us to find CQR. So what is CQR? CQR is this angle. Okay. So this is a slightly tricky question, and all the properties are not very visible. Okay, so notice that C, Q, R, and B this is a cyclic quadrilateral. Okay, so all 4 points are on the circumference. Okay, so if this is 40, this angle and 40 should be 180. Why? Because the opposite interior angles of a cyclic quadrilateral are supplementary. So if we focus on the quadrilateral BRQC, so 40 and angle Q should be 180. Okay, so CQR plus 40 should be equal to 180. So angle CQR is equals to 180 minus 40, which gives CQR as 140 degrees. Okay, so this is 140 degrees. Okay, next, find ABD. ABD. So this angle. Which angle? This angle. Okay, so angle ABD. We know that ABC is 90. Right? We know that this is 90 and this is 40. So all we have to do is subtract 40 from 90 and we will have this angle. Right? So ABD is 90 minus 40, which gives us 50 degrees. Okay, so angle ABD is 50 degrees. Last, we need to find angle ADB. Okay, ADB. Okay, again, very simple. ADB. If we focus on triangle ABD, we know that this is 90 and this is 50. So 50 plus 90 plus this angle, let's call it theta for now, should add up to 180. So 90 plus 50 plus theta should be equal to 180, where theta is basically angle ADB. So angle ADB is equals to 180 minus 140. So angle ADB is going to be 40 degrees. Okay, so angle ADB is 40 degrees. Okay, so in the diagram, points A, B, C, D lie on the circle with center O. AD is the diameter. If AD is the diameter, it means this is 90. So if this is 90 and this is 70, so this would be 20. Okay? And let's mark all the radii. So all lines originating from the center would qualify as the radius. Okay. Find CDA. So what is CDA? CDA. This angle. I think it is very easy if we focus on the triangle ACD. This is 33, this is 90. So 90 plus 33 plus angle CDA should be 180 because angles in a triangle sum up to 180. So CDA is 180 minus 123, which gives CDA as 57 degrees. Okay, so this is 57. Next, find DEC. DEC, this angle. Okay. Okay, so I want all of you to notice and focus on chord DE. So DE is making an angle at the center and angle at the circumference, right? So sometimes it's not very easy to see and some students confuse and think that D is basically it is angles in the same segment. So they think that this angle and this angle is equal, whereas that is not the case. DA is making an angle at the center and then another angle at the circumference. So angle at the center is twice the angle at the circumference. So this is going to be the double of 20, which means it is going to be 40. Okay. So what else do we know? Okay, so we need to find ABC. No, we need to find DEC. So which is that angle DEC? This angle. Let's mark it DEC. We need to find this angle. Okay, so D, E, C. Okay, so let's focus on the chord CD. Okay, so angle made in the same segment are equal. Okay, so since this is 33, angle CED is also going to be 33. Angles made in the same segment. This is the chord, angle made at the circumference, angle made at the circumference. So this and this angle should be equal. So DEC is going to be 33. This is going to be 33. ABC. A, ABC, this angle. Okay, for that we're going to see that ABCD is a cyclic quadrilateral. If angle D is 57, so angle B plus angle D, they're supplementary angles. So let's see. Angle ABC plus 57 should be 180 because opposite interior angles of a cyclic quadrilateral are supplementary. So angle ABC is going to be 180 minus 57, which gives us 23 degrees. Okay. Sorry, 123 degrees. Okay, the reflex angle EOA. EOA reflex angle would be this angle, right? Okay, so we know that this is 180 and we've already figured out that this angle is 40. So 180 plus 40 will be this angle. So let's figure out, let's solve it. So 180 plus 40 gives you 0, 220 degrees. Okay, so the reflex angle EOA, which is this angle EOA, this is obtuse, so they're asking you for the reflex angle, so it is going to be 220. Okay, so in the diagram, ABCDE lie on the circle with center O. BOE is a straight line, so this is a straight line. DAB is 34. DAB is 34. Find X, Y, Z, and D. Okay, so let's see. This is the center, radius, 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 which means this is also going to be Z because this is an isosceles triangle. Okay, and okay, so let's look at, I hope after practicing so many questions which are similar, you're able to figure out that there is an invisible chord at BT, or the arc BD is making an angle at the center and at the circumference. Okay, so the arc BD subtends an angle of x degrees at the center and 34 degrees at the circumference. So we know that the angle at the center is twice the angle at the circumference. So all we have to do is multiply 34 with 2 to get 68 degrees. Okay, so x is 68 degrees because angle at the center is twice the angle at the circumference. Okay. Next, we need to find angle y. Okay, so for that, Let's see. Let's erase this. Okay, so notice that A, B, C, D is a cyclic quadrilateral. So all 4 points are on the circumference. And as we know that the opposite interior angles of a cyclic quadrilateral are supplementary, so y plus 34 is 180. Okay, so y plus 34 should be equal to 180. So y is equals to 180 minus 34, which gives us y as 46 degrees. 146 degrees. Okay, find z. Okay, so because this is 68 and we know that BOE is a straight line, 68, we can figure out what this angle is. Because angles on a straight line add up to 180, so 180 minus 68 gives us 112. So if this is 112, we know that focus on triangle ODE. So 112 plus z should be equal to 180. So 2z is equals to 180 minus 112, which gives us 68. So z is going to be 34 degrees. Okay, so this is 34 and this is 34. Okay, and now we need to find angle T. Let's do the working here. So look at the chord DE or the arc DE. Angle subtended by the chord at the center is twice the angle subtended by the chord at the circumference. So all we have to do is divide 112 by 2 to find angle T. So it's going to be 112 divided by 2, which gives us 56 degrees. So T is 56 degrees.